Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
If you're constantly dealing with databases, you probably have some misconceptions about how indexes work. These misconceptions not only tend to bite you, but they tend to do so at the most inopportune time, when your system is under load or when you've just rolled out a new feature. In this episode, we're going to discuss some common things developers misunderstand about database indexes and how to handle them better. But before we get started, Will, what have you been misunderstanding this week?
Well, I actually just kind of got out of the mess with all the VLAN stuff. I got my network, I think, like I want it now. So now I'm actually moving towards trying to get the VPN working again and getting the various devices where it can connect. And then the next step is setting up a whole bunch of Docker containers and getting those configured like I want them.
Yeah.
And that has proven to be not hard. It's just time consuming because like you start working on it and you're like, well, what if I did this? It's like when you're at that mid-level in code where you know enough to have some options, but you don't know enough to immediately pick the best one. And everything is just like a research dive. It's sort of the pits from that perspective, but it's not bad. I mean, it could be worse. That could be like losing data or something. But yeah, I'm in that phase where you just agonize endlessly over how you're going to do something. But it's fun. I'm learning.
Oh yeah. Lots of fun.
Oh, and I also learned that Portainer will not handle a Docker Compose file that only has a network defined in it and doesn't have any services. And I believe that that's actually due to the underlying, Docker itself. You can't do a Docker Compose, as far as I know, with just a network defined in it, although it may be wrong. There's like a scratch Docker container that you can use. It's basically just like, don't care about this, but apparently that doesn't work at the compose file level. So yeah, I've gone into some weird corners of stuff, where like you ask a question and somebody goes, that's a really interesting question. I'm like, that's the question I shouldn't be asking. That's what that is. So how about you? What questions have you been asking that you shouldn't have been asking?
Oh, I don't know about questions I shouldn't be asking, but so I got the license plate for my truck today. The dealership, they called me Friday. They had it, but it's 2 counties over, or 3 counties over where I bought it. And so I was like, yeah, I'm probably not going to be able to drive out there this weekend. So they mailed it to me and came in today. Then I had to go get the sticker for the county I live in, which wasn't that hard. Just go in, do that. And so tomorrow morning, I'm taking it in to get bed liner put on, spray on bed liner.
Okay.
Yeah. So yeah, I went to pick my mom up at the airport this past weekend. She was up visiting my sister, came back, and she wanted to put her luggage in the bed. And I was like, nope, nothing's going in that bed until it's got a bed liner. So
are you worried about getting scratched or
dinged up? So I'm just like, nothing's going back there.
Because that breaks because that's a spot for rust to come in if you've got scuffs in there.
Mm-hmm. Yeah.
Get you a can of Krylon and go fix it before they put the bed liner in.
Now we just put her stuff in the back seat. I mean, it's a extended cab, so it's got that small back seat. So
I can't imagine her taking that much luggage.
Well, she was up there for 3 weeks.
Yeah.
So
but she just seems like she's fairly efficient.
She is, but yeah, she was up there for quite a while. So 2 big bags, but again, they fit in the back, like in the back seat area. So that was fine. Yeah. And then Sunday is my first Sunday on stage at church.
Nice.
Playing the synth. I was actually practicing before we hopped on the call. That's why I was a little bit late. I thought the song was 5 minutes. It was 7 minutes in the recording. And so I was like, oh, I got time to play this one song. Yeah. Well, it's all right. I was a few minutes late, but that's fine.
Was it Freebird?
No.
That's
It's not
okay.
free version.
I was going to say, it's the short version then.
No, it was Inagata Devita, the 1/16th version. It's like a 17-minute long song, the short version of it. Nah, if you really want to know, it was Came to My Rescue. That's going to be the third song we play, and it's in the key of C sharp minor. No, just C sharp. There's a C sharp minor in the song we played before that. That's what was throwing me off. Yeah, it's in the key of C sharp. So lots of black keys. So my hands are like not used to playing that many in one song. So
it's like using Emacs.
Yeah. Yeah. Getting used to like the hand positions for that. I mean, I've played the song a few times, but still the stuff I've played on stage, it's been like, oh, hey, maybe one or two, sharps in there, but not an entire song of sharps. So just getting used to that and the playing around with the different chord voicings, how I want it to sound. So, at different parts of the song, sometimes you want it brighter, sometimes you want it lower. It's lots of fun. A lot of fun stuff to it. I really enjoy it.
Saving money is hard, especially when you're outfitting a new truck.
True that. That is no joke, man. It's expensive. Lucas Casadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like Complete Developer Podcast, he has a focus on helping you to not only establish a real plan for your future, but to actually act on that plan so that you can create it.
Guys, investing in financial planning services really comes down to whether or not you can improve your finances. And with the help of Level Up, the compounding impact of making better financial decisions will easily pay for itself.
Level Up also has a unique pricing model so that you can pay for it. No matter where you are in your financial journey, it's not too early to start.
Best of all, Lucas is a fiduciary for his clients. And what that means is he's not there to sell you a product, but instead, his goal is to guide you to a better financial situation.
And you can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you are probably dealing with. And he also interviews other IT professionals who share how they navigated their own careers. And he has even more information available at levelupfinancialplanning.com.
Many developers are nervous, and rightly so, when dealing with databases. Not only is the database absolutely critical to proper functioning of the system, but its inner workings can often be rather mysterious to people who aren't constantly in there working with it. Even worse, the database and the data within it are a lot of times the most valuable parts of the application. Making things even more difficult, changes to the database can be near impossible to roll out, especially if data was altered or destroyed by the changes. Small database changes can also have insidious, unpredictable impacts months later, either when the system comes under load or when a large number of records have been added.
Such behaviors mean that unless a developer is very, very comfortable with databases, that they will tend to do things that seem to work well for other people. That's the default. While this does mean that good ideas and good habits can spread around, anybody who has seen how rumors spread in a population is probably well aware that this means that bad ideas will spread further and faster.
Mm-hmm.
It's an environment that really lends itself to cargo cult thinking. And as a result, many developers have got misconceptions about databases. And one thing I've noticed is a lot of them are around indexing. And these misconceptions really sound great in theory, but they aren't so great in practice. In fact, a lot of these misconceptions really can cause major database performance issues.
So in this episode, we'll discuss some developer misconceptions around the database indexes. These are collected from Will's many, many years of experience and include several misconceptions that he had at one point or another within his career. So basically, we're going through Will's mistakes.
Yeah, pretty much. Isn't this the Will's Mistakes podcast?
Yeah. We'll talk about why the misconceptions are misconceptions, as well as what to do instead. Assuming there is like a single better answer instead of, it depends. Indexes can often be used with great effect, provided that they are used properly. But bad indexing strategies are useless at best.
Yeah, like you're hoping for uselessness
Yeah.
because the other thing is stuff catching on fire.
Mm-hmm.
So the first one, and this is one that I see a lot even to this day, and I think it came out of like the bad old days when people did access databases and they weren't really doing super duper complex queries. But this is the thought that if a field is in an index, that index will be used if the field is in a where clause. So, like if you have people's names and addresses, and last name is in an index, and I don't know, zip code is in an index, and they're two separate indexes, and you query on first name equals Bob, and last name equals something else, and zip code is equal to something else, and there's some other third thing, that both of those indexes are going to get touched, right? Because it's not necessarily true, and you might also have a situation where you're searching based on some other criterion, like for instance, you are going, okay, we're searching by last name. Last name is like some value. In some cases, you won't hit the index like you think you will. So just because you think that a particular index is going to get used does not mean that it will. And that includes people that have got a lot of experience. Like you'll get hit by stuff where you're like, I don't understand why that's not getting used. And you'll read some crazy knowledge base article after 3 hours of looking and go, oh, this is why. You really have to check query execution plans to make sure that things are happening the way you think they're going to happen. By the way, sometimes this also means that instead of your index getting used, it uses a better one that you didn't know was on the table. I've had that happen plenty of times too. So like, it's not necessarily always bad, but this is a misconception. And just to add a little spin on this, you'll see people that automatically go, okay, well, because I'm querying on this field, I need to have an index. Now, that's true if it's a big table. If it's a table with a tiny number of rows, it's probably not going to matter.
No, I just thought of something, and we do have listeners at all levels of ability and knowledge.
Right.
And so we did not really define what we mean when we're saying index here.
Okay. Something other than the primary key for looking up is basically the idea behind an index is to essentially have an alternative structure by which I can say, I'm looking for this thing, and it points me to the rows that have that thing. And there's a lot of data structure stuff going on there without going too far over the top with it, but instead of just the row ID, there's some other set of data out here that points at the rows. An index can also, in addition to being like on one to, however many fields are in it, in a lot of engines, you can actually include the values that are in other columns, but they're not in the index.
Yeah.
So I could index on first name and last name, but I could have middle name in there as a value that is stored with the index, so that when I look stuff up by that index, I can get those pieces without hitting the source table.
Yeah, that's what I was kind of getting at, is like not every column in the database, if you think of it from like a table perspective, but not every column in there, not every field in there needs to be indexed.
Right. In fact, most of them do not.
Yeah. Now, going back to this point of where indexes are used, it can happen where you think it's being used and it's not, for a lot of different reasons, especially if the range of the index is too wide, or if, like Will said, happened to him, there was a better index available.
Right. If you have an index over an extremely wide range and you're like, oh, I want to, or you're doing something weird, like you're saying, okay, I want to get everybody whose zip code is an even number. Like a zip code index is not necessarily going to be as helpful as you might think in that structure, because it's kind of range based hierarchical way it gets looked up, without getting again into the data structure stuff, because that varies a lot based on engine. Now, another thing that will get you on this is if you do things that really screw up indexes, like using functions instead of where clauses. Functions, that includes mathematical functions, right? Addition, subtraction. It includes things like string concatenation, includes type conversions, includes regex if you're using that, or pattern matching type stuff, unless your indexing system supports that in some way.
You'll learn a lot of these cases mostly by experience, to be honest. And they're going to really vary between the different database engines, and even between versions of a particular engine. I've actually seen that happen where we updated to, we updated it quite a bit, and so there were some massive changes there. But yeah, it can happen.
Yeah, I mean, sometimes they'll tune stuff. The other thing that can get you that I didn't really point out here is sometimes your index statistics can be really off, or the index can be not maintained well, and the database server knows it and goes, "Hey, this index is crap." Yeah, that field's indexed, but you haven't rebuilt the index after inserting a bunch of rows or whatever, and so it's like I can't trust it, and so it'll pick something else for the plan.
So the next misconception is you can't have too many indexes on a table.
Yeah.
While most of your execution time is probably spent on reading from the database, unless you never insert, update, or delete records from the database, you need to think about how these operations will be impacted by adding an index. And this is what we were saying earlier about not everything needs to be indexed. So you need to be thinking, hey, is it worth indexing this because it is going to take a hit to performance?
Right. And I had this conversation with one of my coworkers today because we've got a table that's got millions of rows in it. And like, I need an index on these 3 columns, and I do not want to put an index on those because it's like our transaction table. It's the innermost guts of the system, and it's already a source of perf issues. There's no way I can put an index on. I mean, heck, even if just the act of putting the index on it will lock the table, and like the system's going to go sideways whenever you do this. And we're just trying to figure out ways to get around it. I think what we're going to end up doing for the operation I need to do is actually make table variables and move subsets of data in and just index there because it's like a tenanted thing that we need to do. But it can be pretty significant in terms of performance as far as like how bad it can hit you. When you think about, well, I guess the best way to put it is you start thinking, okay, well, I'm going to be inserting records. Well, yes, you have to physically insert it in the table, but you also got to update every index that is taking a row value, and it's got to go somewhere in there, and the system has to try to balance stuff out and may have to rework things that may have to move pages of data around, those kind of things. Deletes are the same kind of deal. It's got to get them out of all those indexes. Updates will do the same thing to some subset of fields. So it's never cost free. And when you get enough indexes on a big table, there's also another issue that crops up, and that is the storage of the index, because that's not free either. Even though storage is dirt cheap right now and memory is dirt cheap, they aren't free. And at scale, there is a substantial difference between dirt cheap and free.
Also, you probably don't need as many indexes as you're really thinking, especially if you consider how you can combine multiple indices kind of based on commonly executed queries.
Of course, again, that, one thing you have to think about on that is a lot of times you do have search interfaces where the users put in what they want. When you do that, I highly suggest that needs to live probably on something other than your reporting database. Like at work, I mean, we have mechanisms there for that so that it is not hitting our transactional database for the more sensitive spots, because otherwise people can put arbitrary load on your system and you can't index everything. Your other option is maybe if you write your own ORM, you can just have some mechanism in there to know which fields are indexed and you don't allow searches on the others. I've considered doing that a few times too, but I feel like that's probably a bit beyond overkill.
Now, just like that, you need to set this up based on what actually happens, not based on what you think will happen. I mean, we've actually talked about this in a couple of different episodes for other things too, but like one thing that we as developers tend to do a lot is look at, because when we're building, we're kind of, we're creating and we're building predictively. We're like, I'm writing out this code because I'm expecting it to do this. But we have to step aside and go, oh, hey, I'm wanting it to do this, but that's not what it's doing.
Yeah. Or that's not what it might do under certain circumstances that I haven't thought about, which is usually what happens. Yeah. I mean, that's going to be the theme of this whole episode, right? Is don't do things based on what you think will happen, but do things based on what happened, or based on, what can be projected to happen from real data. So the next misconception is that Databases do a good job of combining separate indexes for a query involving multiple fields on the same table. We talked about this before, but developers tend to think that every field that you use in any query should have its own separate index. Like, this is a junior dev thing that you'll see a lot, but you'd be surprised how often that survives longer than it should. And they'll create it. They'll be like, oh, last name needs an index. First name needs an index. And everybody always queries a database by last name and first name. Well, guess what? First name index is probably not getting used because it doesn't do a very good job of combining on average, especially as things get more complex. There's a really strong misconception out there that the database can always combine those results. I think probably some engines may be able to do this to some degree, but that is a fairly expensive thing to think about. And more than likely, if you're like, oh, it needs to combine these two, it's like, why don't you combine the index? If it's a common enough use case that happens, then fix the index so it doesn't have to be smart.
And when you think about how these indexes actually work in practice, kind of from a data structure perspective, the idea of the database engine combining them on a single table query doesn't really make a lot of sense in most cases.
Right. I mean, it could go, hey, here's all the row pointers that I have from hitting this index, and in parallel, I'm going to hit this other index and get all these row pointers, and then it's the union of those two. But that can get pretty weird when you start doing things like doing ranges on things, and I don't know, an or statement when it gets complex clauses. So like, don't rely on the database necessarily doing that. Instead, if your database metrics show that you're using a more complex query more often, you're typically better doing an actual complex index that addresses that query based upon the statistics that the database is providing. Because you'll have a way to look at your indexes. There's always some kind of views or something where you can get that out and go, okay, what indexes does the engine suggest?
Yeah.
In many cases, it'll actually do that.
Multiple smaller indexes can often really hurt performance, especially on much larger tables. You should always measure to determine whether an additional index is worth the trouble or not.
This is more of a mid-level realization. People realize that using a function as part of a where, join, or order by clause is not a great idea. And for most data types, your where clause really needs to avoid using most functions. There are some functions that you can kind of get away with because the way that the data gets returned is like the indexing system it doesn't affect it. But in general, you're going to want to look things up based on equality or based on them being in a range, right? So, okay, I want dates that are between this date and this date, or where the date value is exactly this, instead of where day of date is 31. And right, because when you do that, now the indexing system, if it's looking at that date, it doesn't really know how to drill down, and so you end up with a scan happening.
Now, the value resulting from calling a function on a column is not stored in the index. So as a result, this sort of thing can often result in scanning all the rows and performing the function on them. Yeah.
Been there, done that today.
I didn't do it. I discovered that it had been done. This was, many years ago. I think I was a junior developer at the time still. And it was a senior developer who had done it. And I think it was just a slight misunderstanding of actually the way that the .NET was like building out the SQL. But I think we talked about that. I had to turn the function into an expression to make it not pull back the entire table and then run the function on it.
Yeah, I had to deal with some of that over the last week, and I'm still not entirely successful with it because it turns out there's some stuff that just there's not index coverage where I need it. This is something that will get you on a lot of stuff. Now, it also will get you on things like string pattern matching. So like the like expression, is this string like Bob %53? Well, that's not in the index, bro. So when it goes to look, it's going to have to scan to do that. Now, it can do some things to go, okay, well, it starts with Bob, but especially when you start it with a wildcard, good luck. I've seen that one happen a lot. If a derived value is going to be frequently used, in other words, like it's a known, I don't know, you got first name and last name and you're combining those to make full name in some way, which by the way, you really can't do
Yeah.
programmatically, just as an aside. But let's say that you're trying this because you hadn't thought about it enough. Well, you're going to want to actually put that value in some kind of calculated column that you can then index versus trying to do a derivation of it for these kind of purposes, especially if it's something more complex than concatenation.
So the next misconception that we have is that data type mismatches in where, join, and order by clauses don't really matter.
Right.
While most SQL dialects do a pretty decent job of transparently converting between data types, except, when they can't.
Yeah.
This functionality should not be relied on in situations where a large number of records are involved, unless the predicate value is the one being converted.
Right. So if I'm saying, okay, where X column equals some value, it's a string that represents a date. And X column is a date. Well, yeah, the value that I'm comparing to, sure, convert that sucker to a date one time, then it uses the index. But if I flip that and that column was I don't know, I guess you could probably do the same kind of situation, right? Like where that column is a string and the other one is a date time. Well, of course, then it'll convert the other way. But there's cases where you really can't do that, where it's not possible to convert from the predicate to the data type being represented. This really is going to be more common in things like joins in that case, rather than where clauses, because you got two different tables full of data, and like neither side is the predicate side. In that case, it's like there's both of them are just a big chunk of data.
For example, if a column is stored as a string and you're trying to see if the values in it are between two integer values, then each entry will require conversion. Whereas if the column is an integer column and you're trying to find the values between two integers that are expressed as strings, it won't be a problem because only two values require data type conversion.
Right. So essentially you just got to look and go, okay, can the engine optimize this and do data conversions beforehand such that there isn't a data conversion involved in the index?
Are you passing in a string that is an integer that can be converted to do this? Or is it, hey, this column is a string, even though all the data in it is integers, and we got to convert them to integers, so you have to convert every single one of them to do this comparison?
Right. That brings up the next thing as well, which is that besides the performance problems that you get out of this, sometimes you can have errors as well because the data type being converted from has a larger range than the data type being converted to. Or if you have like, two strings and one is they're both fixed width or whatever, or they're both, variable width, but one of them can be bigger than the other one and you try to put one in the other. That will definitely create problems, or some values just, can't be converted. So like if you have, I don't know, nullable bools and you're trying to join it and do some kind of projection or something, and the other column isn't nullable.
Yeah.
That'll bust you pretty quick too.
Run into that before.
Yep.
Basically, this can often mean that the query optimizer can't use an index that it otherwise would. And your first warning of the problem might be a severe application slowdown.
Yeah. Or it might go for a while till you get its scale, and then it hits you on a really busy day. That seems to be the way that works out for a lot of people because they don't notice it until it's Black Friday.
Mm-hmm.
And the thing's actually been a pile of crap since March, but Black Friday is when the pile of crap lands on your doorstep.
Oh, yeah, of course.
So another thing a lot of developers think is that the order of simple clauses, put that in quotes, within a where clause always matters, and index selection happens based on those. So like I'm querying where first name equals blah and last name equals blah. And they go, well, there's an index on last name, comma, first name. So I should switch those two clauses. Well, the database engine's smart enough usually to figure that out. Typically, you don't have to help it. I think way back in the day, that may not have been the case, but that was before my time. So you're talking pre-SQL 6.5, you're talking pre-Access 2.0.
Mm-hmm.
It's a while back where everybody was good at DOS back then. So just as a perspective, this is not something you have to worry about too much. And if you do feel like you need to do that to get an index to be used, there's typically a mechanism to use index hints. So you can say, hey, yo dog, when you process this, use this index instead of trying to do it based on the column order, because that doesn't actually tell the database engine anything.
There are cases where the order of statements in a where clause can make a difference, though. But most query optimizers do a pretty good job of handling this under the hood, unless you have a particularly complex query. Now, I've written a few rather complex ones that order did matter. So, yeah.
Yeah. And it's typically, where I've seen this happen more is where you have multiple tables involved and you're doing where clauses in a certain order. And then it can matter because it's like, okay, I have a set of rows that I'm dealing with. And if I put this one first and the database optimizer grabs that first, it will shrink that record set down and it's a smaller filter set. Like that's the kind of context I've seen that in. But even then, it takes some work to get to that point. And that realistically, by the time you're at that point, that may not be your only problem, especially if I'm writing your queries. The order of evaluation of clauses in a where clause is actually not guaranteed under the SQL standard, by the way. But it is possible to choke a query optimizer if you have a sufficiently complex query. Like it tries and it works out it's basically working out an expression tree for how it's going to do its operations. And if something is nasty enough, yeah, sometimes they'll do something dumb.
Note also that by the time your query is complex enough to basically choke the optimizer, it's probably not great for your coworkers either.
Right. And this is something in SQL that is still kind of an ongoing problem, right? Because like in C# or JavaScript, well, okay, I won't say this with JavaScript so much because sometimes there's some weird stuff in there, but like in C#, I can say, okay, I'm going to express this differently. Most of the time, it's not going to really nail the performance that bad.
Mm-hmm.
Right. And I can make it more clear for my coworkers. It might be a tiny little hit, but it's probably not anything. Whereas in SQL, there's a lot of times it's like, look, I can't simplify this enough for the coworkers and the database engine. And the database engine has to take priority because this is the guts of the system. This is the most expensive thing we have.
Yeah.
And so SQL is just under different constraints. But again, to your point, by the time the query optimizer is choking, your coworkers probably are too. That is something definitely to be bearing in mind.
Yeah, sometimes it's not avoidable.
Right.
I mean, I like I said, I've been in a situation where it was not avoidable. We had to, and we did the best we could with what we had.
Yeah, one thing, just a philosophical point, you can still clean that up, right?
Mm-hmm.
And I understand cleaning in this case is not cleaning like a diligent housewife cleans, but cleaning like a frat boy cleans. In other words, you put the dirt somewhere else. And so in a lot of those cases, you'll do something like, okay, I'm running this query and it's nasty, but only the DBAs see it and it puts data in some other table that the devs can hit. You kind of sweep stuff under the rug in those kind of circumstances so that fewer people are impacted by that query and fewer people have to touch it. Mm-hmm. And the people that do are the people that would understand it. In many cases, that means you can't bring it out into the main app code.
Yeah. Assuming you have good DBAs.
Or have DBAs.
That's true too.
We don't. I'm on the team that kind of acts as quasi DBAs, and it's actually working fairly well for the most part. But man, when we get nailed, it takes a minute sometimes. We've got a new guy that's actually really, really sharp. So he's probably going to be more of a quasi DBA than we are, I think. But
yeah, that's true. So the final misconception we're going to discuss is that you should rebuild indices every night because they rot. Ooh, those rotting, nasty indexes.
Yeah. So indexes do degrade over time with use.
Yeah.
Right. Like there's no such thing as bits actually rotting in a system to a point where we have to worry about it at our level. right? Like other stuff is badly broken by that point and the system isn't going to load. But data changes can degrade indexes over time, especially if you're doing like bulk insertions, bulk deletions, doing a lot of updates. The thing is constantly changing. And it can especially happen if there are a large number of records, in the database. The indexing process cannot keep up with everything because it's, a lot of cases it's going to try to do that out of band so that it doesn't kill perf on everything that happens. But sometimes it doesn't keep up or it gets fragmented. Honestly, a good way to think about it is a lot like the old Windows defragmentation process. Actually, that's probably not a good way to think about it because most of the people listening to this probably don't remember that.
No.
With the little squares and it's got to move pieces around to get it where it can.
Oh, I remember those.
Yeah.
Now, in particular, because of the tree structure used in a lot of the indexes, they have a tendency to become fragmented or lopsided, like you were talking about. Meaning that the queries for certain values are much more expensive than similar queries for other values.
Right. You'll also see this. At one place I have seen some weird stuff happen as well as with GUIDs. So if you have GUIDs as an indexed field and the way you're generating those GUIDs is not semi-predictable, it's like, hey, here's a random GUID, that index will be all over the place.
Mm-hmm.
It's a pretty wide range to try to do a search. And so you're going to have some that's like, oh yeah, this is the first one in this range. It's the only one there. And then there's some other one over here that's got 10,000 in it. And it's got to do more jumps basically to get to everything. You can do some stuff to kind of optimize around that. So this is something I've seen a fair bit. But again, index maintenance should really be performed only on the indexes whose fragmentation and other issues exceed a particular threshold. And it'll tell you, like, hey, this thing's 20% fragmented or 20% out of date or whatever. Or when you've churned the data a lot, like you've onboarded a massive new client. That's when you do it, and you do it based on what's actually happening in the system, not what you think is happening. And by the way, you can still write queries that figure this stuff out, so it's still automated. It's just don't blindly drop and rebuild all the indexes because especially if you're hosting an AWS or something, you're paying for that process that isn't really doing any good for you in a lot of cases.
Yeah. Even if you're not hosting there, it's still
heat, electricity, and disk wear and tear, and the possibility of stuff going wrong, is another thing. It's also downtime in a lot of cases. It can really bite you a lot.
Mm-hmm.
So guys, there are a lot of common misconceptions about how database indexes work. We could not have covered 10% of them probably here. I probably have some that I don't know about. But if you haven't spent a lot of time studying how databases work at a low level or thinking about how they might have to look something up from a actual like data structure perspective, it's really easy to end up with a mental model of databases that don't really match reality. And as a result, many developers do have misconceptions about indexes that can seriously harm performance when they implement stuff based on that. If nothing else, a lot of these ideas can waste a lot of developer time and cause frustration for team members as problems mount. And worst of all, these misconceptions often don't cause problems until the worst possible moment, aka Black Friday, aka something where all the executives are looking, seeing how much money they're about to make, and you screwed up their money making. That's a real unpleasant place to be. However, if you can avoid these kind of misconceptions and actually measure stuff before you take action instead of doing cargo cult thinking, you'll tend to write better SQL code, especially over time. You'll get better. And if you get nothing else from this episode, it's really important to understand one thing. Measure your results when you make database changes rather than making assumptions about what those results will be. And that's all we've got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod. like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.